Hey, what's up guys? Nick here, and I wanted to fill you guys in on a little something that I've been going through behind the scenes for the last few years here. You see me making fishing videos all the time, but you probably noticed that I live on a private lake. I am no water expert. I know a lot about fish, but I don't know about the water and the chemicals. And we had a die-off here, and the lake was looking pretty bad, and I was encouraged by the other members to join the board, and I said, well, I needed to get myself educated on this, and I got passed along a name, Eli, and then Eli was saying, we got to meet his boy over here, Landon, and I was talking about safer ways of treating the lake. I was just like probably the rest of you guys. I'm hearing about chemicals, and I'm hearing how it's a bad thing, but the more I find out, the more wrong I actually was in regards to that. Now, yes, using anything in an excessive amount could be a really, really bad thing. But Eli's been informing me a lot lately on preventative treatments in lake management. So what I'm going to ask these gentlemen to do is go over a lot of the common things that we see, ways to treat the water and pick their brain. They're both fantastic experts in the subject. I am not. I know very little. I don't want to show you from the outside of the window in. I'd rather walk you into their house and let you sit right down in front of these guys and pick their brain. So I'm going to try to ask them the questions I think we've all been wondering. You guys up for that?
Let's do it. Sure, sounds good.
Awesome.
This device is called a Secchi disc. It's used to measure visibility in lakes. It was invented almost 200 years ago, and scientists called limnologists who study lakes have been using it ever since. So we still use this to measure the visibility, the depth you can see in the lake, and we use that to determine a lot of aspects about the health of the lake. We classify lakes often by how deep you can see in the lake. So now we'll measure with this device as deep as we can, and we'll record the measurement of how deep we can see.
Did he say sucky disc or suck a disc?
That's what my mom says every time I talk about it. So a Secchi disc is named after Father Angelo Secchi, who invented and used this disc in the Mediterranean Sea in the late 1800s.
Is he the guy who should actually get credit for it?
Well, that's another story altogether.
You guys should send him a royalty check.
Yeah, right. George C. Whipple is a guy from America. Actually was the one who painted the disc alternating black and white, and he is the one who should get the credit for this device being used in fresh water. The original Secchi disc was used in salt water in the Mediterranean Sea. So I've just about lost visibility on the disc. So now I'll measure where I can see. I'm measuring just about 6 feet of visibility, so 2 meters.
Wow.
That's actually pretty good, and that indicates a pretty healthy lake.
Did you say pretty or really?
It's pretty good. Lake Tahoe's visibility with the Secchi disc meter measurement is around 200 feet.
Yeah, but Lake Tahoe could suck a disc.
Oh! Basically what this is going to tell me, you can actually use formulas based on the measurement I read. The formula will actually be able to basically let me know roughly about how much phosphorus exists in your lake. So I could take the 6-foot measurement, add, and then calculate out how much phosphorus you have. And if I know how much phosphorus you have, then I can predict how much algae is going to likely be growing in your lake.
Really? Just off the visual?
Just off how deep I can see this disc in your water.
That's crazy.
Yeah.
I had no idea.
Because that was first painted by an American, you could say if you use a Secchi disc to measure the water quality in your lake, then you love America.
Yeah, that's right. That's
true.
Absolutely true.
America.
Yeah. God bless America.
So the most common thing I think we all notice when it comes to lakes, rivers, what have you, ponds, is algae. Can you break down some of the common types of algae and explain what the hell we're looking at?
Sure, I can make it pretty easy to understand. So,
okay.
There's all different types of algae. The important thing to remember when you have a lake or you have a pond is that algae is a vital, important part of the food chain.
Algae's good.
Algae is good. Just like anything else, when you have too much algae, becomes excessive, then it can start causing issues. You know, it can cause a problem for fishing. If you have too much algae, it can block out sunlight in your pond, disrupt the food chain. Algae can die off, and it can cause a massive oxygen depletion and end up as a fish kill. So it's all about monitoring the different types of algae that you have and keeping that algae in check. You don't want to wipe out algae because you're wiping off an important part of the aquatic ecosystem.
So I'll break this down, and this is coming from a fishing standpoint and a complete novice in this subject.
Right.
When the water is just all hazy green, that's planktonic
Planktonic algae.
algae.
Sure.
So I kind of mispronounced that one a little bit. Not so bad. The big clumpy cheesy looking stuff on the bottom is the filamentous algae that got out of control and is now on the surface.
Nailed it. Awesome.
Okay. What's the last one? String algae. Is that a real algae?
Filamentous algae. Again,
Filamentous algae. That's still filamentous algae. So that's early on.
There.
Early on, that's that stuff growing up.
Sure.
Off the bottom.
So it can be attached or unattached filamentous algae. So sometimes it's attached to a substrate on the bottom, breaks off, floats to the top, and sometimes
so the floating mats are detached and attached.
Sure. Yeah.
Could be looks almost stringy. Look kind of globby.
Right.
It's the stuff I don't want my toes touching when I'm swimming.
The third type that you're probably referring to is what most people refer to as blue-green algae.
I knew that. Where were you?
Which is actually a bacteria, cyanobacteria. So technically, not even an algae. And that's the stuff that is in the news all the time that you hear about the most. That has the capability of producing toxins.
Okay, that's the blue-green.
Sure.
And now I heard if you treat that, there's a higher odd of it becoming toxic. Is that a particular type, or what is that?
So all types of cyanobacteria can produce toxins, and they can produce a vast range of toxins.
Okay.
You know, we hear about some of the most prevalent or the most common or most well understood types the most often.
Okay.
So microcystis producing microcystin, and there's a few other ones out there.
So when we hear about a blue-green algae breakout, how did that happen? How did that come about?
So
what causes that to happen?
Well, it's a pretty detailed answer. We can delve really far into this. But the layman, the easy way to explain it is excessive nutrients.
Okay. Excessive
nutrients into a water body over a period of time, and your water body becomes eutrophic or hyper-eutrophic, and ends up producing blue-green algae or cyanobacteria.
Okay, so I'm going to act like I know what I'm talking about right here.
Let's do it.
And he was talking about measuring the phosphorus levels, right?
Right.
And there's a certain level, if your phosphorus levels are too high, that's where the algae starts becoming excessive, correct? And below is not an issue?
Right. So ultimately, whenever we have a lake, we're interested in classifying that lake to some degree. All lakes age, same as a forest, same as any other landscape you might have. You have, when a lake is formed, so to speak, it's a young lake. We call that an oligotrophic lake.
Toddler, yes.
Right. And if you measure the amount of phosphorus or other nutrients in the water, the visibility, you'll have very low nutrient levels.
Okay.
Very high visibility. The more nutrients you have, the greener the water becomes, the more plants you have, because all that nutrients is really the base of the food chain.
And is that just plant life decomposing, running from the hills, from the creeks, soils?
So the process
plants?
is totally natural. As Landon called it, eutrophication is the process of a lake getting older.
Okay.
And it'll go from oligotrophic to mesotrophic to eutrophic, all the way to hyper-eutrophic.
I could spell all of those.
You could spell all of them, right.
Easily.
It's
Easily.
Essentially, the word is just a fancy word for meaning nutrient-rich.
Okay.
And what we're just talking about is measuring how nutrient-rich a lake is, and that tells us the age of the lake, essentially.
Okay.
Not all lakes age the same, but all lakes will age. And those nutrients can be natural. They can come from dust and pollen, ash from nearby forest fires, and a number of other sources, just regular exchange with the atmosphere. It's a natural process. But when we have man-made lakes, or we have lakes in areas where there's a lot of development, especially agricultural development, we see a lot more inputs, whether that's fertilizers, lawn care products, industrial wastes, and other sources of nitrogen and phosphorus and other micronutrients that eventually, the more development around the lake, the more of that stuff winds up in the lake.
So it's like feeding the lake fast food.
Feeding the lake.
Right,
And
we're speeding up the natural process.
speeding up the natural, and that's why we've actually been seeing in the last 10, 15 years, that combined with changes in climate, we've seen a much more higher prevalence of these blue-green algae blooms in America and across the world.
Fascinating. Okay, very cool. Okay, so we got stuff entering the lake, the junk, the plants are decomposing, our lake's getting older, and now we know our phosphorus levels are going to be higher to where we're naturally going to start producing more algae. Am I right on that?
Yeah.
So what can we do to combat that? These guys are chemical specialists and natural, what would you call that?
Natural control
Is
methods.
that more of like a biologically safe
Right.
method?
Right. We
So
use biological
how could we
products.
combat it, man?
The best way to combat it, the smartest way to do it, would be using an integrated management approach. And that involves using every tool available to you. You know, really trying to understand your water body, understand its needs, and then selecting the best tools from there. Whether that is biological products like we make, whether that is chemistry like Algae makes, or it could be using aeration or fountains or a number of other tools. But it's about using everything at your disposal and making the correct decisions to have the
Best results.
Sure.
Okay, so with that being said, Landon, what I've done is on this private lake here, we're only 20 acres, so we can easily fluctuate our water level up and down, and I'll let it dramatically go down a couple feet and shoot it back up, and it seems like it's making the plant life trying to grow shallow and the algae struggle. I don't know if that's from the water temperature fluctuation or the vitamin D from the sun penetrating, but I know a lot of lakes don't have that option, and sometimes the sun will be blasting, the UV rays will be so high, the algae starts to get out of control, and we've used copper treatments. And I've seen people freak out around the lake. They're dumping chemicals in the lake. What is copper, Eli? Is it safe?
Copper is a safe product. It's been used for thousands of years. We've used it in...
I've been using it for $599.
Yeah, that's right. It's been around a long time. And it's a proven safe product. It's really a go-to product for folks that use that water for irrigation. Because it's safe on food crops. You can't harm your trees. You can't harm your lawns and your ornamental plants with it. It is a micronutrient that plants need. And what happens in a lake setting is essentially, to oversimplify it, the algae or even plants will take in too much of the copper. And it ends up disrupting their membranes and harming the cells of algae. It's perfectly safe for people. In fact, the rates at which we're allowed to drink it in our drinking water is well above the rates that we can harm algae and plants with in the lake.
Now, I remember we were testing the water back in the day, and I think our phosphate was like almost like a 6. And you told me there was this like upper 4s or mid 4s. It's probably a good idea to get ahead of it and use some other management. So if someone's testing the water, how would they test their phosphorus levels?
Well, there's a lot of labs around. You could take water samples and send them to the lab, and every lake is going to be a little different. So, if we're just going to use some arbitrary numbers, if your lake is at a 5, well, that might be okay. But in a different lake setting, a 5 might be producing lots of algae. Because it's not just the one parameter you're interested in. You're going to need to understand all of the parameters and how they work together. So when we do our copper product treatments and we do other treatments, we try to work with companies like Landon's company, because that allows us to combine the biological tools, which are going to address those levels of nutrients and micronutrients in the pond. So while we're possibly killing algae, instead of allowing all that nutrients to flow right back into the pond, we're also addressing some of these root causes and not just treating the symptoms.
Okay, so by killing all that, we're increasing the nutrients, so therefore we are continuously aging to where it can happen again, right?
Exactly. That's
so
right.
this is where Landon's company comes into play.
Right.
Fill me in, brother.
So we make a couple different types of products, but they're all biological products. The most important products for these applications, Eli's referring to our probiotic line. So these are products that contain bacterial cultures, so beneficial bacteria,
Okay.
And different stimulants, you know, proteins and amino acids.
And do they
things like
feed off
that.
the same stuff that the algae feeds off of?
Yeah, so they compete. They compete for the same nutrients. Essentially, when you're adding these products into the environment, the additional bacterial cultures and stimulating the natural occurring bacterial cultures that are in your environment. So these are going to break down your proteins, your starches, your lipids into simple sugars, amino acids, and fatty acids. So you're reducing the organic matter, and let me go back a little bit. Then they are going to use those in their bacterial metabolism.
So let me get this straight. Let me see if I understand this correct. These are brilliant individuals, guys, and I catch fish for a living. So let me see if I get this straight right here. So instead of necessarily killing them, now we're making them share the food source to where we're yielding their growth.
Absolutely. That's a fair way to put it.
You did it.
Yes.
Fair way to put it.
See? He can be taught. He can be taught. That's awesome, man.
Now, is this for a cattle ranch, someone you dislike, or pond management?
This is actually the modern version of what we call the Secchi disc. This device here is used by lake managers, and we can measure about 16 different parameters in a lake with this. I can look at the turbidity, which is another way of looking at visibility of the water, the clarity of the water. I can also look at other important factors that we now, as modern scientists, know are important to lake management. Things like how much dissolved oxygen is in the water.
Really?
Do I have enough oxygen in the water for my fish?
Ah.
pH. pH is another important factor when we look at the depth of the water at the bottom of the lake. What kind of conditions are present in the lake? We also have other things we can look at with this device, which would show us things that indicate whether or not there's pollution occurring.
Really? Okay.
So this particular device, I hook up to my phone, and how's that connection looking?
It's coming along, about 40%.
Okay, so what we do with this guy, it also measures the depth at which it is in the lake. So you simply drop it in the water and let it register the measurement, and Landon would click the button that would record the measurement. Once he does that, I'll simply drop it a couple feet, read the depth on the screen, and then record the next measurement. And you can keep going all the way to the bottom of the lake, recording the measurements as you go. So
that'll register the different depths as you're dropping, so your depleted oxygen.
correct. It'll register and record the information at the different depths in the lake. And this allows me to determine whether or not a lake has sufficient dissolved oxygen. It may decide whether or not we need to increase aeration systems in the lake, if we need to add aeration systems, or if those aeration systems aren't working properly. Other factors affect dissolved oxygen, such as just the amount of algae and plants in the water. Through photosynthesis, of course, they're adding oxygen to the lake. So if you were to do some sort of control method where you were going to remove or kill the plants with possibly a chemical treatment, dissolved oxygen would be a really important factor to take into consideration. Because if you have low dissolved oxygen to begin with, then you could potentially affect the fish in the lake and other organisms.
So you choke them out.
You'd choke out the fish. If you remove the plants and algae and you already have low oxygen, then you have nothing adding the oxygen back into the system. So, dissolved oxygen is an interesting chemical condition in lakes that's unique. When you typically think about dissolving something, the warmer the water, the more you can dissolve into it. Oxygen is one of the few components that's the opposite. The colder the water is, the more dissolved oxygen you're going to have. This is actually comes into play in California quite a bit because we see a lot of fish kills happen late in the summer. And typically that's a result of, like right now, we have 80-degree water. Well, the amount of oxygen that can be held in this water is pretty minimal. So if we were to do any drastic changes to the plants right now at this time of year, we could potentially deplete that oxygen even further and end up killing fish.
So for my scenario right now, we have lots of pondweed. What was the one you called it with the little seedling on top?
Sago pondweed.
Sago pondweed. Now, let's say if we were to treat that right now, we wanted to get a hold of it. What's like a good chemical to use at that point? I know you talked about manually removing it. Is that because of the risk of the dissolved oxygen?
There's a couple reasons why you would want to look at multiple strategies for controlling the plants in this lake. Ultimately, you want to do a combination of strategies right now. And if you were to do a chemical approach, there are certain chemicals you can use that basically stop plants from growing and will prevent plants from eating food, making food from photosynthesis.
Okay.
Those are the safest type of products you can use because that mode of action doesn't harm fish or mammals or you or me.
Okay.
It only affects plants
Right.
by stopping plants from being able to photosynthesize, converting sun and carbon dioxide into energy.
Okay.
So-
And that's strictly just so they don't take over the whole dang
And
lake.
that's basically to stop them from growing out of control.
Okay.
And they're very safe products to use. Alternative types of products are ones that are going to kill the plant immediately. We would call that a contact herbicide.
And that would affect our
And that
dissolved
rapid
oxygen.
death is going to create all kinds of bacteria and other organisms start eating the decaying
Right, and they
plant
use
matter.
it as they start consuming that biomass.
Right. And that's what's going to eat up more of the oxygen. So not only are you removing the elements that are creating the oxygen, but you're depleting the oxygen further by having them decompose rapidly.
Okay.
With the products that kill the plant slowly over a longer period of time, you have less of that oxygen depletion occurring.
Okay.
Now,
Nice.
now that's an important thing to talk about, but also keep in mind you don't want to treat when it's not necessary. You know, you want to. Sometimes you can come in a situation like this. It looks great. You have good clarity. You have a good amount of growth in the lake right now. It looks to be pretty healthy.
Okay.
When you want to worry about dissolved oxygen is when you have an overabundance of growth in the lake as well. Because if you have an overabundance of growth, it doesn't happen very often in California. But when you do have a few, cloudy days in a row, these plants or algae are going to be consuming all that oxygen, and so you can deplete oxygen really fast. Again, have a fish kill.
Yeah.
Okay. That may have been what happened a few years back.
That's right. To clarify, what actually happens is a lake breathes. Once a day, it inhales and it exhales.
Mm-hmm.
During the day, when the sun is out, you have photosynthesis occurring, which is creating oxygen.
Okay.
Once the sun goes down, the plants still need to continue to produce energy. So they reverse the process where they start to actually consume the oxygen to continue to feed and grow.
I never once thought about it that way.
Same
That's
thing with
wild.
algae. So what happens is in the day they're making oxygen, at night they're sucking up all the oxygen.
Got it.
So you do have that potential early in the morning usually, right before the sun comes up, the oxygen is so low, you'll walk out in the morning and you'll see dead fish floating in your lake. And that's a
Wow.
natural process that occurs. This device is called a Van Dorn sampler. We use it to take measurements of water at discrete depths in the water column. So what I do here is I attach these devices, these lids here in the center, and this metal piece will be called the messenger. It will hit this button and release the two ends. So this allows me to collect water sample directly from the very bottom of the lake or somewhere in the middle of the lake, so I can avoid any contamination of things that might be floating on the surface of the water.
Best device for accurate samples.
Simply lower it down, just like this, and release the messenger. So we simply pull the device back up. There you go. Thank you. And then I got the water I need right here.
I think the most important thing to understand if you're going to manage a lake, as Landon talked about, there's an integrated approach, and there is no silver bullet to control and to solve your lake problems. The key to success is going to be utilizing every tool in the toolbox. So like you were talking about manipulating the water.
Yeah.
That would be what we call a cultural control method.
Okay.
You're manipulating the environment through your management practices to change temperature, to change sunlight, and that's making the system inconducive or not hospitable to algae and certain plants. Well, Lance's components make sure that we're competing for those nutrients at the base of the food chain. And that combination with adding things like dye, pond dye, which will prevent sunlight. If you don't have sunlight, you're not going to have any growth. So
Look under your boat docks. There's no
right,
growth.
exactly, no growth. So the key is going to be to find every tool that you can afford to use. And when you study the lake and think about which tools and which combination of tools, because the ultimate goal is the reduction of any one tool. We don't want to over-rely on chemicals. We don't want to over-rely on biologicals.
Right.
We need an even combination that's going to give you your best chance for success, and it's going to be the healthiest for the environment.
So when you hear these guys talking about a management plan, it's don't wait for it to get out of control. And that's kind of what I stepped into when I stepped into helping manage the lake here, is I didn't know what I was doing. It was getting out of control. And in the beginning, I kept hearing pond management from Eli, and I'm asking Eli for the silver bullet. And Eli's trying to explain through his teeth to me that there is no freaking silver bullet, Nick. We need to focus on pond management. And the reality, when they're talking about pond management, it's about maintaining a healthy balance coming right out of winter, right? You know, that's what we're normally treating in early spring, to where we're combating the nutrients to yield our algae growth. Sonar was there's a couple of what is that?
Sonar is a brand name of products.
Okay.
The active ingredient is called Fluoridone. My company makes a brand. We call it Fluoridone.
Fluoridone, okay.
Fluoridone is an interesting product. It actually prevents plants from photosynthesizing.
Okay.
Essentially. And what we do by adding that in the early part of the year, we can target certain locations, or we can do whole lake treatments. We're going to slow down or prevent plant growth in certain areas of the pond. And that's a great way where you can then share the pond. You can target certain areas for your recreational activities.
Okay.
And you can also leave some parts of the pond
So it's good to have
untouched.
some. It's good
Definitely.
to have
Plants and algae are the base of the food chain.
some. And they produce oxygen
They
as well.
produce oxygen.
Okay.
They help clean the water quite often. So utilizing those tools is going to be a great method to prevent some plant growth from getting out of control, but also too much plant growth, as we talked about, can't just be a nuisance, but you can actually end up harming the pond if you let the plants get too out of control.
Okay. Now, is that because they're dying and it's becoming too much nutrients, or is there another thing? I know you were telling me during the day that a pond wakes up and then it sleeps, right?
That's right. So we saw this happen a couple times. It's actually a natural process.
Okay.
It's called a fish kill.
All right.
And fish kills can happen for a number of reasons, but one of the more common reasons...
Not just me.
Not just you, that's right.
Happens everywhere.
It happens everywhere. It's a natural process, and there can be a number of causes for it, but one of the most common ones is during the day, when the sun is out, all the plants are photosynthesizing.
Okay.
Byproduct of that is oxygen. That oxygen is in the water, and the fish need it. Well, at night, when there's no sun, the plants will actually consume that oxygen, plants and algae. So if you grow too many plants, they can actually use up all the oxygen they've created throughout the day, and you'll end up with no oxygen in the pond. And that's usually when you see those naturally occurring fish kills early in the morning. If you see a depleted oxygen, those fish will be dead in the morning when you walk out on the porch.
Yeah, I've seen that, yeah.
It also
it's not
happens,
during the middle of the day, yeah.
Yeah, it's not during the middle of the day. It also happens in the delta, where we see all of these invasive species. They grow so rapidly that they will deplete the oxygen during the evening. Or they'll also, sometimes floating ones will cover the tops of the entire river in some cases.
Yeah.
And they'll shade out the light, ultimately leading to zero oxygen environments, which will kill any aquatic organism that's living
wild.
there.
So by using that product, and I'll list all the products in the video, guys, and I'll list their companies and how to contact these guys, both super awesome dudes. So by using that product, we're yielding that plant growth to create a healthy balance, and at the same time, like with his products here, we're making the algae share the nutrients, so we're yielding the algae growth and we're yielding the plant growth, so therefore we're slowing down the aging process of our lake. It's not turning into sediment, which is going to increase our algae growth. And by using his product at the same time, now we're making everything share, so now that is a management solution. This whole circle's coming together.
Absolutely.
I'll tell you what, just sitting here right now, I've gained a much better appreciation of the understanding of what's been taking place, even though I've been heavily involved with it. And we've been treating with, what did you call it, Fluoridone? Fluoridone for the last 4 years out here, 5 years, I believe, actually, which is a great product. And that's about measuring the size of your lake, and Eli is going to show you some of that along the way on how to do that to figure out how much you need. This is all really critical, guys, if you want to grow big fish, if you want all your small life to be healthy, if you want your crawdads to be healthy, your big bass to be healthier. Management is a big part of that. The better the balance, the better the oxygen, more food source, just everything works out better to grow these bigger, badder fish. Very, very cool.
One of the least monitored water quality parameters is alkalinity, and alkalinity can be very important for a lake or pond. So alkalinity, when you boil it down, is essentially the water's ability to neutralize acid. So more calcium carbonate means higher alkalinity. Eli, why don't you tell them why alkalinity is important?
Hold on, I got a short little story, real quick. So we were fishing at Pyramid Lake, that's where the Glahat and cutthroat trout in Nevada, and it's super high alkaline, okay? Or that's probably, I'm saying that wrong or something, you guys probably
nailed it.
But, oh, yes! So anyhow, the guys forgot to tell us to rinse off our waders. It ate all the strings and everything out of our waders. Our waders were leaking like crazy. Anyhow, back to Eli.
So, right, alkalinity is a really important parameter to be measuring in your lake. Especially a lot of people use chelated coppers. My company, Algae, we make a product called Argos copper. It's an algicide you use to kill floating mats of algae or planktonic green water algae, and a lot of people use it, but they don't realize that if the alkalinity in that pond is really low, that you need to use a lot less of that copper algicide. Because what happens with the alkalinity, if it's too low, that copper can be more toxic to fish, so you can actually end up harming the fish. So it's important to have a device like this. It's a small $50 little device that'll measure the alkalinity in the water. Alternatively, you can also use little test strips you might buy for like an aquarium at the fish store, at the pet store. Essentially what we do, we take a little bit of the water and we'll use this device. First thing I'll do is I measure the background of the water, stick it in here. I hit the button and it will measure the device, measure the water sample. Then I'll take it out and I'll add a little reagent to this product. I won't do it now for the camera, but ultimately I'll put in about a milliliter of this reagent. It's going to change this thing colors. When I put it back in, this is going to then read what the alkalinity is. This water, I would guess, is probably, what, 50 to 80, something like that?
Good guess.
Moderately alkaline water.
What it tasted like to me.
But ultimately, that's going to tell me how much copper algicide I can safely use in this water body. So alkalinity is an important factor, as Landon said, in understanding the pH of your lake as well, and knowing if that pH is going to fluctuate widely. Wild fluctuations in pH can also affect fish, especially if fish are already sick or have some sort of illness. Major shocks to their system, such as pH swings, can start killing off your fish too.
Constantly hearing this from my neighbors and stuff too, and I honestly felt the same way in the beginning, is our lake didn't look like this for the last 20, 25 years. And now this probably already makes sense to you that you're seeing we're getting more sediment, more nutrients into the lake and more nutrients into the lake. And they're out here treating my lake right now. And this is with a chemical, not a chemical, excuse me.
A biological.
Biological
Yeah.
treatment. What is this, Landon?
Yeah, so we call it a probiotic or a biological product. So similar to the probiotics that you or I would take.
Okay. I don't know.
You or I or any of the audience would take.
Yeah.
Or their wives.
Okay, let's see.
other
Their
person.
wives would take.
Yeah, there we go.
You may be into fitness.
be
I'm all
healthier.
about fitting whatever's in this mouth.
So with the idea to improve the microbiota in your gut, for example, so the microbial community that lives inside of you, that we're finding out more and more is responsible for different parts of your health, or plays some part in different role in your health. So
I think he's judging us.
So probiotic for your lake or your pond works very similar.
Okay.
So you are adding these beneficial bacteria and stimulants to reduce the excess nutrients and organic matter that are found both in the water column and on the bottom of the water body, that left unchecked would continue to increase and continue to feed more algal and more plant growth.
So essentially, they're out there applying the fountain of youth.
Yeah, essentially.
In a sense. Now, you were talking about a pie,
That's
and you were showing me a pie, and it could be a small pie of certain nutrients sharing the ultimate piece of the pie. And he explained that Landon's product here is decreasing the overall size of that pie.
That's right.
Because you can only fit so much into the pie. My lake was aged out to where we're maximal size of the pie.
That's right.
And now we're decreasing it. So can you kind of elaborate on that a little bit?
So when you started out the conversation, you said my lake never looked like this before. I used to work in lakes as a lake manager. Right? What did you do to my lake? Or why should I do that? Why do I need this chemical? Why do I need that product? I've never had to do it before. Well, we all said we know that lakes age through eutrophication. But what we really need to think about is all of that nutrients in the lake is the base of the food chain, whether it's the nitrogen or the phosphorus or other micronutrients. That makes up the size of your pie. How much of that nutrient do you have at the base of your food chain? Okay. Every wedge in the pie is a different organism. You got your fish, your plants, your algae, your bacteria, all of the other organisms that are living in there. If you remove one of those wedges, the pie now has a hole in it.
So that's a silver bullet treatment, is removing a wedge.
If you were to use some chemical and just completely remove one wedge.
So if I said I need it crystal clear tomorrow,
right?
Now we're talking about completely eliminating a wedge.
You've eliminated a wedge. What's going to happen? Mother Nature hates a void. It's going to fill that. And what's going to fill that? Whichever wedge grows the fastest. And that's probably going to be algae.
Okay.
So what we do, and the reason we worked with Landon and we brought him out here to help manage your lake, is because I have one set of tools. I can help you shrink and reduce a wedge, but I need to make sure in a proper management strategy that I've got somebody like Landon with his tools to actually increase the size of the other wedges in the pie. So it's going to be a combination of reducing wedges, but also filling and widening those other wedges. And the thing that we've done today is we've taken the whole size of the pie, and by removing the nutrients, we've actually shrunk the overall size of that pie chart. Okay. So the wedges are still interdependently connected and about the same ratios, but we've eliminated the abundance and the size of each of those wedges today by stripping the water column of phosphorus primarily today.
So Landon's product is about being a master of wedgies.
It's a wedgification.
It's process. A wedgification. It's a wedgification process.
A de-wedgification.
Now, with the wedgification process, Landon, we're talking about, a lot of people want clear water. What are the pros and cons for clean water versus dirty water? Just because you can't see very deep doesn't necessarily mean the lake's unhealthy, right?
No. So this goes back to what we were talking about earlier. So it goes back to talking about what you're trying to use your water body for, right? You can't have crystal clear water, no algae, no plants, and expect to have a 15-pound bass in your water body. It's not going to happen.
And we need that.
Right. Exactly. That's super important. If you have really clear water, you can expect more sunlight to get down to the bottom. And what's going to happen when you get more sunlight down to the bottom?
More growth.
You get more growth, right? If you have not enough sunlight penetrating the bottom, what's going to happen?
Less growth.
Right? So it's really about identifying what you're going to use your lake for and deciding, do I want it crystal clear? Do I want it, is fishing not a priority for me? Do I want it to have a little bit of growth in it so I can have a balanced lake and I can do a little bit of fishing and a little bit of recreation? So really it's about managing the clarity of the lake.
I think that's a really important point, and I think that that's an expectation anybody who lives and works on a lake needs to understand, is that we're sharing that lake. We have our expectations and our intended uses, but there's also some other uses of that lake that we need to share it with the environment. We need to share it with wildlife that uses it and relies on it. We need to understand that, yeah, it's nice if I can swim and not get tangled up in weeds, but do I have to clean the entire lake to do that? Or do I just need to clean the beach areas? Right? And it's important, and if we look at this lake today, it's a perfect healthy mix. I've got pretty good clarity. I can't see the bottom everywhere, but I don't need to.
Right.
I have a nice healthy amount of algae growing. I've got some plants growing. It's providing forage, it's providing food, it's providing ambush protection, it's providing shelter for fish. So it's a healthy balance. And having unrealistic expectations about water clarity or what a lake is supposed to look like usually leads you to mismanaging your lake.
And setting those expectations is really important as well, because even if you wanted your lake to have 10 feet of clarity, not every lake is capable of sustaining that type of clarity no matter what you do.
That's like removing too many pieces of the pie, right?
Exactly.
Right. Asking for a bigger problem.
Right.
Yeah, ultimately, attempting to manage nature is always a difficult process. And there's always going to be factors that are outside of your control. You can't control the sun, you can't control the temperature, right? And at some point or another, you're going to lose control if you're trying to hammer everything down all the time. And so it's better to understand that it's going to be a dynamic process. You're going to want to be proactive, but you're also going to have to be flexible and dynamic as the environment shifts and changes, as inputs shift and change, as the weather changes, as rains come, as development occurs in your neighborhood. You can't go and tell your neighbor not to stop raising cattle.
So an interesting,
he's got a right to do that too.
I'm going to stay on this subject, but we're talking about lakes that were populated and have a lot of people around them are going to get all the nutrients they need. And I've recently seen some things online where guys are talking about fertilizing their ponds, and that's adding nutrients. And this is not for like an area like this, right? Where would someone fertilize a pond?
So down south.
Down
is
south?
honestly the most common answer. So up north, where a lot of the lakes are, they're surrounded by homes and communities and people and farms, and getting nutrients into the lake in a variety of different ways is not a problem. There's enough nutrients to go around and feed plants and algae and fish and other organisms in the aquatic ecosystem. Often down south, as a result of the types of soil that they have down there in these water bodies, they don't have enough nitrogen or enough phosphorus.
So that's why they need to
so they'll actually fertilize it so they can grow some plants or grow some algae to act as cover or feed every other organism in the environment, so they can grow these 10-pound bass. And if they didn't fertilize it,
they would stay small.
Yeah, they would stay small.
Very, very interesting. Now, okay, along with that, we were talking off the camera about the big bad blue-green algae and golden algae, and these are scary things. You heard about it. Down south, my buddy Joe Everett lived on a trophy lake and it got golden algae. It killed all the fish, and then you hear in the Delta about blue-green algae, and we got blue-green algae in Discovery Bay, and this is a little cove area that's just surrounded by houses. If these guys were going to take a preventative action in the Discovery Bay area, what do you guys believe the best preventative action would be to combat that blue-green algae coming before the warmer season?
Okay, so that's a really tricky one, because Discovery Bay is a very big body of water.
Yeah, it is.
And you got a lot of sources. I mean, we're talking about the Delta. It's the largest delta west
of Mississippi.
It's a tidal system, right? It's a tidal system. So we really need to look into really broad policy action.
Okay.
On the news just the other day, I was hearing about some rivers and systems out in Washington, D.C. It's still illegal to swim in those water bodies there to this day.
Wow.
Because of all the pollution that's occurred. Over the years of people dumping sewage, industrial processes dumping waste. Well, back in '74, Nixon created the Clean Water Act and the EPA, and over the last several decades, we've identified the sources of these pollutions and we've cleaned it up. We've made regulation for industry to not allow them to be dumping pollutants, to make people manage their wastes better and their construction debris. And so it's really a bigger, broader process. And it's not going to be something where we can say, what can I do today to stop it from happening this year? But how do we change our behavior overall as a state, as everybody who's in the watershed that's feeding that system? How do we all incrementally improve the products we use in our houses, the products we're putting on our roads, the products we're using as detergents in our systems that are going into our sewers? All of that water is eventually at one point either going into the ground or going back into those rivers. So how do we create new policies in the long run to really impact it? There's not going to be any silver bullet solution, but that's the most important.
Something that may be more relatable to you, maybe talking about how do I prevent a harmful algal bloom from happening on my lake.
My
something
lake, yeah.
something this size. And that's something that we can do, or we can work on.
Yeah.
Where we have a realistic opportunity to affect what grows in there. And I'm going to say it involves using the integrated management approach we were talking about earlier. So being proactive, making sure that you have enough dissolved oxygen in your water body, right?
So for a tidal system, that's extremely hard to control then, huh?
At this point.
At this point. Wow.
Some of the tidal systems do get enough oxygen, others don't. It's very variable. But Landon makes a really good point here, which is if you want to have a preventative system in a lake like this, we need to use all of the tools at our disposal. Those are going to be biological control methods, things that are going to compete with those algae and prevent them from blooming. We're going to use some chemical controls, because if we do see them starting to hop up, we need to bang them down before they start doing things like the golden algae and killing our fish. So there is a chemical need in there, but we also want to do everything we can to minimize the amount of that chemical needed and use that chemical in a safe way. And the way we do that is we have aeration in the pond that does a number of chemical processes in the pond. It will increase oxygen, but it also reduces the likelihood of more nutrients being released from sediment. So we're going to address that nutrient issue with biological tools, with some physical controls. Sunlight and temperature can be controlled with things like pond dye. So we can use those tools as well. And then there's also physical removal. If I have a lot of plant growth, it's actually really beneficial for me to go out there, scoop up those plants and get them out of the system. Actually get them out of the lake and out of the watershed, so they're not going to decay and go right back in the pond. So removing all those plants is removing nitrogen and phosphorus that's in the plant tissue.
Wow.
So you have to look at all of these integrated strategies: the physical, the chemical, the biological, and the cultural. Like you did, you manipulated temperature by manipulating the water levels.
So would you say it would be a good idea to invest in a hippo or a manatee for my body of water?
Definitely a manatee.
I am too lazy to get in there and rake it out.
I'm much more pro hippo than I am manatee. That's personal thing.
I'm team manatee all the way. I'm obviously me and the manatee have got a lot in common.
Great information. So ultimately now, when I think about pond management, and feel free to correct me if you think I'm wrong at all, it's about making sure there's a natural balance of plant growth, making sure our phosphate levels are in control, making sure we have an equal balance of the pie, and if our nutrient levels are too high, making sure we combat it with a natural treatment like you have here, along with like a fluoridone. Correct? Am I correct about this in general?
That's part of it. Yeah,
that's definitely part of it. Now there is one piece of the pie which is missing, so to speak, from the discussion here, which is invasive species management.
Okay.
And invasive plants come into a system. They might come from your local pond store where they're selling pond plants, like the Delta Hyacinth.
Yes.
This is a major issue in California.
Yes, absolutely.
This is a plant that has no nutritional value to any of the native species. And as a result, it grows out of control.
Okay.
When it grows out of control like that, it just devastates and kills an environment. It will suffocate the lake, it'll suffocate the slough or the river, and it will become unmanageable. And it doesn't matter what you try to do to manage the balances, because it is an invader.
Okay.
Hence the name, an invasive species.
Yeah, milfoil, hyacinths, there's all sorts of invasive species, right?
Right.
That get out there. And that is kind of, that's probably one of those times where you have to hit it with the silver bullet and then kind of recreate balance, right?
Well, the silver bullet's a tricky question. Like I said, there is no silver bullet. I used to work for a company that we were hired to go and mechanically remove the hyacinth. We had these gigantic machines.
I've seen them out on the Delta.
Yeah, we were out there scooping stuff up, slowly moving it, 10 yards at a time, 10 cubic yards at a time, looking at a river that had millions of cubic yards of material in it. It was an endless battle. It was part of the project, part of the struggle to try to combat this plant that was taking over and killing our delta. But ultimately, it might cost you $50,000, $60,000, $70,000 a day to run a bunch of these machines.
Put me down for two.
Right. And you couldn't do that. There's not enough money in the state to run enough machines to scoop all those plants out.
So what did they use to treat the Delta hyacinths?
Well, they still use a a Roundup-based product, a glyphosate-based product.
Okay.
They also use other products in there as well.
Now I want to stop you real quick.
Yeah.
When you say Roundup, all I've ever thought about is the Roundup I spray weeds in my garden with.
Right.
And I see causes cancer, is harmful. We see them spraying Roundup in the Delta. I've literally seen bottles that said Roundup, and I freaked out. Why the hell are they spraying Roundup in the Delta? And I've actually seen dead fish and dead animals in these areas. Now, I just recently found out because of you, this is an entirely different type of Roundup, correct?
That's right. So my job is actually, I'm what's called a pest control advisor. It's a certification the state gets you. The goal of a pest control advisor is to minimize the use of chemical and to use chemicals safely and effectively.
Okay.
But my goal is to try to do everything I can to minimize that use of chemical. Although I do represent a chemical company. When you're talking about these chemicals, there are over 300 different chemistries that we can use on our lawns, we can use them on our trees, we can use them in railroads to prevent plants from growing. Well, of those 300 or so different chemistries, there's only about a dozen that the EPA, the United States Environmental Protection Agency, even allows you to use in, around, or near the water. And they undergo a lot of testing to make sure that those products are safe when they're being used according to the label and being used properly by a professional.
So they need to be trained properly.
Absolutely need to be trained.
So
they
if you apply this wrong, you can cause harm.
You absolutely can cause harm.
Okay.
Ultimately, these products, when used according to the label, are safe to be used. They do have a lot of testing they undergo on animals, just like other products that we get, consumer products we have to use, and they are able to determine how safe or dangerous that product is at different concentrations. So ultimately, just because you have a Roundup product that you would maybe use on your lawn, that is actually, while it has the same name, it's not actually the exact same product that is being used in the rivers and lakes and ponds.
Okay. And for me, I never seen that difference there. I wasn't even aware of that. So if there is dead fish in that area or dead animals from that, do you think it could just be the person applying it being uneducated and going overboard? Is that a possibility?
That is, of course, a possibility. I would think that more likely than not, what you're seeing are, firstly, in some of the, if you're visualizing the areas I'm thinking of that are completely covered with these products, with these plants, the invasive species.
Oh yeah.
We've killed off those fish and those organisms anyway. There's nothing growing in there. It's a dead zone.
Okay.
Because it's completely covered off from any sunlight. There's no oxygen in the water. So when we start killing and removing those plants, whether it's with chemical or mechanical, you're going to start seeing the things that died as a result of that invasive species. The actual amount of chemical they're applying is very, very low, and it shouldn't be enough to harm any of those animals in an acute toxicity sense. Most of these chemicals we use affect plants specifically. They affect a certain mechanism in a plant, and that mechanism doesn't exist in mammals, it doesn't exist in fish. So that chemical doesn't have any effect on those other organisms. It only does things like stopping plants from turning green, which plants need chlorophyll to make photosynthesis. So humans don't photosynthesize, that chemical has no effect on us. So that's why herbicides are a much safer tool. Some pesticides, don't get me wrong, are very dangerous. Insecticides, you should be very careful with those. But ultimately, if you look at the back of the label on a lot of products, a lot of the things you have under your sink, even nicotine, caffeine, bleach, these are much more dangerous products to fish and the environment.
Not to mention, if you don't come up with a management plan or a way to treat these invasive species and you let them grow, you're being even more irresponsible to the environment, and ultimately you're going to cause more harm to the environment as these invasive species spread.
You're just going to let it keep going and going
right,
and going.
You got it.
Right, you're going to end up with even a bigger problem. One thing that's nice the state has done, my company makes a product called Imox. Imox is a Mazamox. It's considered a reduced risk pesticide.
I love that in my Jamba Juice.
Yeah, it's good stuff.
Yeah.
The what they call the tox package, the toxicity package, meaning it's very, very safe product for fish, for organisms. The state has switched over and started using that. One of the greatest tools we have these days now is finding ways to use Landon's products in conjunction with my products. Because when I combine the biological power of his tools with the chemical activity of my tools, I can reduce the amount of my chemical that goes into the mix. And by adding his, not only are we addressing the symptom, but I'm also addressing that cause, And when those plants die and sink to the bottom, we're not letting them recycle back into the cycle of nutrients and regrowth.
So the
more
nutrients
plants.
is being consumed at that point.
It's a match made in heaven.
Right.
So not only less chemicals, a safer route, and you're not adding to the previous problem.
Right, and even,
right.
even if you're not using less chemicals, even if you're using the same amount on a treatment, you're getting them into their target more efficiently, very often by adding something that's very safe, like a biocatalyst, that
Awesome.
improves penetration into the plant.
So guys, hopefully what I hope you take from this is understanding if you have a young lake and you haven't seen a problem, problems may occur. If you're in an area that has a lot of homes around a lake, be prepared if this is going to happen. Look at the biological way of combating that. The Floridone's a fantastic way to keep your plants in check. Maybe you don't need to go overboard on treatments early, but start developing a pond management system or a lake management system. It's not only going to help your lake maintain its youth, it's going to help out create a better balance. It's going to be better for the fishery, better for the health of the lake. Your odds of getting blue-green algae are going to be lower. It's just safer all around. It's going to build a much better system for you guys to fish and play in all around. Eli, brother,
Pleasure to see you again.
my man.
Thank you.
Absolutely, guys. Thank you for coming out.
Yeah.
Thank you for being so smart. I love it. I love this when I can talk to these guys and they struggle to break it down in layman's terms. So luckily, you know, I've been picking his brain so much on the side that I was able to absorb some of this extra, and I think it really helped me kind of understand it. If you guys have any questions, feel free to put them in the comment area. I'll see if these gentlemen are ever interested in checking those out and answering them. If you guys want to check out their companies, make sure to check out the links below. I'm going to lay it over this video. I'll put a time spot down there so you can go back, rehear these things. Anything you see in this video, if you want more details, ask below. These are two fantastic gentlemen. They know their stuff. They're all about lake management and doing it the right way, guys. Chemicals are not a bad thing. A much more natural biological approach is a great thing. Yep. But at the same time, Landon knows he has to do it at the same time with chemicals. Absolutely. For bigger problems with, and that's where Eli comes into the equation. So remember, this is something that has to be done. This stuff spreads. Golden algae can get picked up, blue-green algae can get picked up into a storm and added to a new lake. So if it never existed for you guys in your area before, that doesn't mean it can't happen next year. So just be prepared, you know, keep that gun up in your cabinet to protect your home, so to speak. InformativeFisherman.com, guys. Appreciate you watching. We'll see you next time.